All right, hello. So here I am. I've connected to the Pitzer cluster at OSC via ondemanda.osc.edu. And so within our workshop, we're going to submit a set of sample calculations. We're going to compute the hydration free energy of a drug-like molecule in water. And so in this screencast, I want to take you through setting up, essentially in this case, equilibrating our system. And so I have scripts to essentially automate the process, scripts to, one, make it easier for you, but then two, whenever we look at a new system, we're going to essentially follow the same protocol. And so by automating things as much as possible, hopefully we can, make it as easy to, look at other systems as, other systems as well. But then preparing scripts also helps to minimize potential errors. Okay, and so when you apply, what you learned in this workshop to other systems, hopefully the changes you'll need to make are minimum. You'll need to generate force field files and things of that nature for your systems of interest. But in general, you should be able to take what we have here and reuse that. So in this screencast, I'm just going to quickly go through everything, do the bare minimum to equilibrate our system and get things running. I'll then have another screencast in which I go through things in more detail and try to explain all the files and look at them. And then there'll be, that again when we get to free energy calculations. So after the system's equilibrated, to submit that free energy calculation. Okay? All right. So let's do it. So I logged on to the Pitzer cluster, and so I'm placed in my home directory. All right, we've got 500 gigabytes of backed up storage space here. But we're going to navigate to our project space that's been set up for the workshop. So our project is PMIU0186. So I'm going to navigate to our space as cd/fs/e ss, and then we're PMIU0186. Okay, and when I do that, I'll see two directories in this folder. One is a directory with the force field files that we'll need for our set of calculations. And then the second is a sample directory. Okay, and what I want you to do is copy the sample directory and create a directory with, say, your username. So my username's MIU0105. This way, if you need any help, you can point me to your folder and I can go in there and help you out. Okay, so I'm going to open up MIU0105, which I just created. Okay, and essentially, we're going to start by equilibrating our system. So kind of the stages to equilibration is first we need to generate an initial structure, and then we're going to perform a basic minimization with Gromacs to remove any bad contacts that may have been created by Pacmol. Then we'll equilibrate, first using a Berenson thermostat and barostat. So remember, Berenson doesn't sample the correct ensemble, but it's very stable. And then we'll perform another set of equilibration with stochastic velocity rescaling thermostat and Pernella-Raman. So we're sampling the correct ensemble. And then that'll give us our starting structure that we'll use for our free energy calculations. All right. So again, in this version, we're just going to get everything set up and running. So I'm going to start by opening up initial config. Okay, if I type ls, here I've got a Pacmol input file and a script to run Pacmol and generate that initial structure. So all I need to do here is run this script. So it's going to be a period / initial config. So this will go through packing the box with Pacmol. So it'll generate an XYZ. Open Babel will convert the XYZ to PDB, and then I can use the PDB with Gromacs to convert the PDB to .gro. Okay. You saw a couple of error messages. It's nothing to worry about. It's just in the XYZ files I use for each molecule, I use non-standard atom types. Right? So OW is water oxygen. Here's a water hydrogen. But Babel's saying, hey, those aren't on the periodic table. And MW is my imaginary site. This is TIP4P water. Okay, so it looks good. Main file I'm trying to get out of this is this input.gro file, which is our starting structure. So then next, I'm going to back up a directory, type ls. We've got our initial configuration. Now we're going to go to minimization. Okay, so cd minimization. Purpose of minimization is to remove any bad contacts that may have formed. Okay, so I will need to edit setup.sh. Okay, so I'll vim it. Then I'll also show you how we can do the same thing graphically. Okay, but I'm going to vim setup.sh, and the one and only thing you'll need to edit here is down here where the set command is. I need you to update the email address which is used in the job submissions file. Okay, so currently in the submission file there's my email address. I want you to update it with your email address. Right now it says you@you.com. You're going to replace this with your email address. So if you're using Vim, right, I could type I and get into insert mode and change it. Okay, but assuming that most of you aren't comfortable with Vim, okay, so if I quit out of here, the other way is, remember, there's this file navigator. So let me kind of go through it again. But under files, if I go to our project space from the drop down, and I see my folder here, okay, I'm in minimization, and I need to edit setup.sh. So over here, I'm going to say I want to edit setup.sh. And what I want to change is this second email address right here. So I'm going to delete you@you.com, and I'm going to type in my email address. Okay, you type in yours. I don't want a lot of emails. Okay, so I type in my email address, click save. Okay, so then once it's saved, I can close it. And just to confirm it's been updated, if I vim setup.sh over here in the command window, right, it's been updated. So then you just need to run setup.sh. So again, that's a period / setup.sh. Okay. So in terms of warnings, all right, so we get one warning and it's okay. It's just that whole issue of names and how I name the atoms, but you don't need to worry about it. Okay, and so it's just one warning, mismatching atom types, which is okay. Then once that's done, what I need to do next is I need to submit my job to the scheduler. It's going to run on the supercomputer. So to do that, the command is just sbatch, and then submit job.sh. Bam is the name of my submission script, and that is it. So if I were to type qstat-u, and then my username's miu0105. Okay, I could see my job. It's stuck in queue. Okay, I could keep checking on it. Hopefully it'll start soon. But I'd submit the submission. So I submit one submission script. Okay, what it's going to do is it's going to run my minimization. Then once the minimization is complete, it's going to propagate the necessary files so it can perform my 2 steps of equilibration. The idea is I'm going to wait in line. The minimization calculation should take all of like a minute, and so I don't want to have to go back in and submit another job just to get to those other 2. Okay, so it looks like it just started running. All right, I can see that files are starting to come in. Okay, when I see these steps, right, typically that's okay. It's it might have some bad configurations or large energies initially, and it's just saving a snapshot of my system. So if I were to look at the log file, all right, so we're at 2,854 steps, right? So things are going okay. So once the minimization is done and complete, it'll propagate the necessary files and run my 2 stages of equilibration. Then once that's done, all we're going to need to do is you're going to need to submit your free energy calculations. And to do that, I just open up the FECalc directory. And again, first your equilibration needs to be done. And all that I need to do here is I'm going to vim FESetup. Okay, is in the setup script. Again, you just need to update your email address. Okay, so if you're not comfortable with Vim, I can move around and get to FE calculation via this file navigator, and I would just want to edit FE setup. Okay, and so I'm just going to edit what's down here. Right, so this you would want to change to your email address. Okay, save it. And then once that's done, you're just going to run period backslash FE setup and then a period backslash FE submit. Okay, so do a period backslash for FE submit. So basically what we have is when we perform our free energy calculation, we're running 14, like in our case, 15 independent simulations. So rather than typing S batch for each and every case, quite literally what FE submit does, right, is I just copied and pasted that 15 times, so that you just run it and it'll take care of everything for us. Okay, so give that a try. I'm gonna stop this recording and I'll go into another one in which I go through some things in greater detail.